Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, motion topic we are going to discuss. So in our previous videos, we learnt about scalars and vectors, their examples, vector notation, types of vectors, and the distance, displacement, speed, velocity, change of velocity, acceleration, average instantaneous acceleration, uniform acceleration or constant acceleration, non-uniform acceleration, deceleration, and about equations of motions we have discussed. First equation of motion, second one, third one, and some problems. After that, graphs we have studied, displacement time graphs, and first type, second type, third type, and some conclusions. After that, velocity time graphs we have studied, when it is parallel to time axis, how to calculate slope and area. When it is not parallel to time axis, when it is a straight line, starting from origin, starting from some other point, in that case, slope and area we have calculated. And when the velocity is decreasing, in that case also, slope and area we have calculated. When velocity time graph is a curve, that we have studied, and some about conclusions we have studied. Next learn our today's topic regarding acceleration time graphs. So acceleration time graphs. So here acceleration means rate of change of velocity. How the velocity is changing, in how much time, how much velocity is changing. If the velocity is increasing, it is called acceleration. If the velocity is decreasing, it is called deceleration. It is also one kind of negative acceleration. So here, the below figure, this figure represents acceleration time graph. Acceleration time graph. Here, AB. AB is the acceleration time graph, which is coinciding with time axis. The acceleration time graph AB is a straight line, but it is coinciding with the time axis. On the coordinate axis, on the y-axis we have taken acceleration, on the vertical axis we have taken acceleration, on the horizontal axis or on the x-axis we have taken time in seconds. So here AB line is coinciding with the x-axis or time axis. So if it is coinciding with time axis, its y value, y coordinate value at any point, here 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. If you check at any point on AB line, in every point the y coordinate is 0. Y coordinate means the value of acceleration is 0. Means there is no acceleration in the body. When there will be no acceleration? When there is no change in velocity, or when the velocity is uniform, at that time acceleration will be 0. So here acceleration is 0, which means the body is moving with uniform velocity. So whenever the acceleration time graph is coinciding with time axis, we can directly say that the acceleration of the body is 0, or the body is moving with uniform velocity. Next, case 2. The figure represents an acceleration time graph, AB acceleration time graph, which is parallel to time axis. So in this case also, at any point, here 1, 4, the coordinates of the point are x value 1, y value 4. Here x value 2, y value 4. 2, 4, here 3, 4, here 4, 4, at every point y value is constant, means acceleration of the body is constant, 4 meter per second square, which is not changing, which is not changing. So here what we can tell this condition, the body is traveling with uniform acceleration and variable velocity. In the previous case, zero acceleration. In the previous case, the body is traveling with zero acceleration and uniform velocity. But here, in this case, the acceleration is not zero, but the acceleration is constant. Means the velocity is changing, but the change is constant. So that's why acceleration is constant. So in this case, we can tell it is traveling with the uniform acceleration and variable velocity is changing, variable velocity, but the change of velocity is constant. So that's why uniform acceleration. So as the acceleration is not changing, so the body is moving with the uniform acceleration and variable velocity. So in this case, the area of the graph, if we draw perpendicular lines from A and B to the x-axis, we will get a rectangle, and the area of this rectangle gives the velocity, gives the velocity of the body, Next, another case. The figure represents acceleration time graph. So AB, here acceleration time graph is AB, moving away from time axis, as well as moving away from acceleration axis. Means neither parallel to time axis nor parallel to acceleration axis. So in this case, if you check at any point, so here 1, 2, 2, 4, 3, 6, 4, 8, 4, 8. So the acceleration is changing and velocity will be changing. So in this type of cases, both the velocity, both the acceleration will change. So body will be traveling with variable velocity and variable acceleration. And the area of the graph, if you join with coordinate axis, area of the graph gives the velocity. Here, area of the graph means from B point, if you draw a perpendicular line, it will intersect x-axis at a point C. So area of the graph is half into base into height. So half into base into height, half into AC into AB, or AB into R. One minute, children. Half into AC into BC, children. Of AC into BC. So in the graph, values are not given exactly, children. Values are not given exactly. Here 1, 2, 3, 4. 4 seconds. Here acceleration this is wrong, children. So half into AC value, if we take up to 4, up to here, if we take up to here, AC value will be 4 and BC value will be 8. So half into 4 into 8, 2 times 4, 2 8 times 16 meter per second is the velocity. 16 meter per second is the velocity of the body. Like this, we have some cases to learn. Still, some more cases are there which you can learn in your higher classes. This is about acceleration time graphs. So the chapter completed, children. So let's revise the concepts, definitions and formulae which we have learned in this chapter or which we have discussed so far. Let's revise the series of points. So first point, the quantities which require only magnitude means only value. Magnitude means like 10 meter is a magnitude, means product of numerical value into standard unit is called magnitude without direction. So the quantities which require only magnitude for their complete specifications or complete description and having no direction associated with them are called scalar quantities. One minute. And like time is a scalar quantity which will be having only the magnitude. Next, quantities which require both magnitude and direction for their complete specification or complete description, they are called vectors. Such type of quantities are called vectors. Example, velocity, force, acceleration, displacement. These are all vectors. Next, the physical quantities like electric current. So normally in our house we will make use of electricity or the electricity which is in flow. It's called electric current, which will be useful for running our electric appliances in our home, like the refrigerator, television, like so many electrical equipments. So that kind of quantities, they possess magnitude and direction, but still they are not vectors. Though they are having both magnitude and direction, but still they are not considered as vectors. And any form of energy is a scalar, like solar energy, chemical energy, nuclear energy. Any form of energy is a scalar. So next, representation of vector. So a vector can be represented by a straight line with an arrowhead. So what are like vectors or what are parallel vectors? Vectors which are in the same direction. If AB vector is pointing to this direction, if BC vector also have the same direction, then they are called like vectors. If their directions are different, they are called unlike vectors, anti-parallel vectors. If they start from same point, they are called co-initial vectors. If they end at same point, then they are called co-terminal vectors. If AB vector, if this is AB vector, 5 meter length towards each direction. We have another vector 5 meters length in west direction, which is BA. Both are having same magnitude but mutually opposite to one another. Then this BA, this is AB vector, this is BA vector. Then BA vector is considered as negative vector of AB. Suppose this is 5 meter towards east, another vector also 5 meter towards east. If they have same magnitude and same direction, then they are called equal vectors. Or the vectors which are acting in the same plane, their magnitudes and directions may be different, but if they lie in the same plane, they are called coplanar vectors. So this is AB vector another vector BA also, another vector BC also lying on the same line. Means the sum of the one or two vectors, if they are lying in the same straight line, they are called collinear vectors. Suppose one vector is having 5 meters magnitude and east direction. Suppose if this vector is AB bar vector, if any vector is divided by its magnitude, like modulus of AB bar, then we will get unit vector of that particular vector, because 5 meters towards each direction is divided by 5 its magnitude. Then 1 is 1 meter, means 1 unit towards each direction. If any vector is divided by its magnitude, then its unit vector AB cap, then its unit vector will come, means which is having unit magnitude and whose direction will be same in the original vector direction, whose properties are same like the original vector. So that is called unit vector. Unit vector is represented by cap, means 1 unit value. So zero vector, a vector which is having zero magnitude but some direction, is called zero vector, or another name null vector. Next, proper vector, means vector whose magnitude is not zero, it is called proper vector. So position vector means in the coordinate axis, a vector which originates from the origin and which terminates at some other point in the coordinate system, it tells the position of that vector. So that is called position vector. Non-planar vectors. If this is one plane, if this is another plane, the vectors acting in this plane and the vectors acting in another plane are considered as non-planar vectors, because they are acting in different planes. Next, displacement time graphs. If the graph is parallel to time axis, then the body is stationary. If the graph is straight line but not parallel to time axis, then the body is moving with uniform velocity. If the graph is a curve, then the body is moving with variable velocity. So the graph line can never be parallel to displacement axis. If this is displacement, if this is time, graph can never be parallel to displacement axis. Why? Means if it is so, in same time the body will be having different displacements, which is highly impossible. Means the displacement increases, or the displacement increases indefinitely without any increase in time, which is highly impossible. So velocity time graphs. When the velocity time graph parallel to time axis, body is moving with uniform velocity. So when the velocity time graph straight line but not parallel to any axis, the body is moving with variable velocity. When the velocity time graph is a curve, the body is moving with variable velocity, variable acceleration. So equations of motion: v equal to u plus at, one equation; s equal to ut plus half at square; v square minus u square equal to 2as. Equations of motion means they are applicable for uniformly accelerated bodies. They will give the relation between the quantities v, u, a, t, s. When a body is moving with a uniform acceleration, then the relation between final velocity, initial velocity, acceleration, time, displacement is given by 3 equations. They are known as equations of motion. Okay, children. Remaining problems we can discuss in our next video. That's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. So please visit our website, children, www.aimstoday.in for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.